Okay, so for the next example, I need you to remember a few things. Sometimes we don't know our angle measure, but we have information about our angle. So in this case, they give us two pieces of information. They tell me that my cosine of my angle that I don't know, but it doesn't matter, but I do know the cosine's ratio is -3/5. And they tell me that my angle, again, I don't know what the angle measure is, but it doesn't matter, but I know it's in quadrant 3. So quadrant 3, this is quadrant 1, quadrant 2, quadrant 3 is over here. So my angle, theta, in standard position would go from here somewhere over into quadrant 3. Okay, so again, my reference angle is here, and if my hypotenuse is 1, because we purposely make the radius of my circle 1, so my hypotenuse, we purposely make 1, and the cosine we've said is going to be the adjacent length, which is here. That's the adjacent length. It's the same as my cosine. And I want you to start noticing that it's also the same as our x coordinate, right? We're at the origin, we're going left. And that's why, because we're going left, that's why we get a negative cosine ratio, because we're going negative x divided by a positive 1 adjacent over a hypotenuse, right, is going to be a negative value. So what about the sine? The sine is the opposite length, right? So I'm going to write opposite. Sine is opposite. And I want you to start thinking of it as the y-coordinate of this point right here, right? So yes, we went left, that gave me a negative x, and now we're going to head down, that gives me a negative y-coordinate. So my sine is going to be negative as well. So the right triangle that we have here is still a right triangle, so the Pythagorean theorem still applies. So that means this distance squared plus this distance squared will be equal to the hypotenuse squared. Well, we purposely made the hypotenuse 1. So the hypotenuse squared is this 1 right here. This distance, which we said is the cosine squared, this leg here, which we said is the sine squared. So leg squared plus leg squared equals the hypotenuse squared. This gives us what we call the Pythagorean identity. So it's always true for any angle if you took its sine length and squared it plus its cosine length and squared it, it's going to be equal to the radius squared, which we purposely made 1 in all of these situations, so that the cosine would be the x-coordinate and the sine would be the y-coordinate. So we purposely done that. So let's use this Pythagorean identity to find the other trig ratios when we know the cosine is -3/5. So let's see. So we're going to rewrite our Pythagorean identity, sine squared of theta. And that's how we say it. We say sine squared of theta. I want you to understand that we don't put this square on the right side of this angle because I don't want you to think that the angle measure is being squared. It's the ratio itself that's getting squared, not the angle, but the ratio. So plus cosine squared of theta equals 1. And let's replace what we know. So we don't know the sine, but we do know the cosine. So we'll replace the cosine with -3/5 squared. It's the ratio that's being squared is equal to 1. And then let's just simplify and solve for this sine of theta, right? We want to know the sine of theta. So we're going to simplify. So a negative squared is going to be a positive answer, and 3 squared is 9 in the numerator, 5 squared is 25 in the denominator, is equal to 1. Now, when I subtract this ratio of 9, let's use this red. So I'm going to subtract, because I want sine of theta all by itself. So I'll subtract 9/25 from both sides of the equation. Right? I want you to think of this one as 25 over 25. Anything over itself has a value of 1, and I need common denominators to subtract. So sine squared of theta remains on the left side of my equal sign, and this goes away, and I end up with 25 minus 9 is 16/25. So 16 is in the numerator, 25 is in the denominator. So I want sine of theta, and right now I have sine squared. So we're going to take the square root of both sides of my equation. And I'm going to remind you that when you solve by taking the square root, we always have to consider the positive and negative possibility of the solution. So I've taken the square root of a square, so this gives me sine of theta is either going to be the positive square root of this ratio, so square root of 16 is 4, square root of 25 is 5, or the negative possibility of 4/5. So again, I go back to which quadrant I'm in. I'm in quadrant 3, and those y coordinates or signs are going to be negative. They're headed in the negative direction from my origin. They're headed down. So I'm going to get rid of this one, and my answer is -4/5. So we'll try that again on an angle that looks a little bit different. So let's go here. Let's see. Let's go here. There we go. Let's go here. So we are here at B, and we are going to use our Pythagorean theorem, our Pythagorean identity, sine squared of theta plus cosine squared of theta is equal to 1. That's our Pythagorean identity. And this time they don't blatantly tell me what quadrant I'm in, but they do tell me that I am, my angle in standard position is between 0 and pi over 2. So I'll remind you that 0 is here, and then pi over 2 is the same as a 90-degree angle, so it's up here. So because my angle is somewhere between 0 and pi over 2, I know it's in quadrant 1, and that tells me that both my cosine and my sine are going to be positive values, which I don't know what my angle is, but I know that it is in quadrant 1, so it will have a positive cosine and a positive sine. And we see this positive cosine right here, positive. And now I know my sine will also be positive. So let's replace what we do know, right? So I don't know the sine yet. That's what I'm looking for. And I do know that my cosine is square root of 2 over 2, and I'm going to square that ratio. Cosine squared says take the cosine ratio and square it. And so now we'll simplify. So sine squared of theta plus the square root of 2 times itself is 2, and this 2 in the denominator times itself is 4. Right, and so now we're just going to solve for sine of theta just like we did in the previous example. So let's subtract 2 fourths from both sides of my equation. Remember that if I have 1, I'm going to rewrite it with common denominators. And so I get sine squared of theta is equal to 4 minus 2. This goes away. 4 minus 2 is 2 in the numerator, fourths. And then to solve for sine of theta, we have to take the square root. If I take the square root, I need to think positive or negative possibilities. So square root of sine squared is just sine of theta. And then either the positive square root of 2 in the numerator over the square root of 4 in the denominator. Square root of 4 is 2. Okay, or maybe it's a negative. Square root of 2 is my numerator. Square root of 4 is my denominator, which is just 2. But because it's in quadrant 1, we decided early on that the sign was positive. This is my answer, and I don't need to worry about that one. All right, we're going to do that one more time. So I'm going to start with my Pythagorean identity, which is sine squared of my angle plus cosine squared of my angle is 1. It doesn't matter what my angle is. I can still find the cosine given the sine as long as they tell me what quadrant we're in. So we're now in quadrant 4. So let's go here. To get to an angle in this quadrant, I would have to go in the positive cosine direction and then a negative sine direction. So my sine is negative. That makes perfect sense, right? Because I'm headed down. But my cosine from my origin was headed right, so I know it's going to be positive. All right, so now I can just substitute in what we do know into the Pythagorean identity. So I know my sine is negative 0.8, and I'm going to square that ratio, plus the cosine squared of theta equals 1. So now I'm just going to simplify and solve. So negative times negative is positive, so anything negative squared is going to be positive. And then 0.8 times itself is 0.64. So plus cosine squared of theta equals 1. I'm going to subtract the 0.64 from both sides of my equation, so that the cosine squared of theta is 1 minus this is going to be 0.36. And then to solve, we would take the square root of both sides, because I need cosine of theta, not cosine squared. So cosine, or square root of both sides, positive or negative possibilities here. So cosine squared, and take the square root as just cosine. And then we decided early on that it was positive cosine, so I'm just going to worry about the positive square root of 0.36, which is positive 0.6. So the negative 0.6 would have been in one of these two quadrants, but positive if it's over in this right half. All these positive x's are my positive cosines.